Hi, in this video we're going to be working with algebraic manipulation in order to be able to evaluate our limits. We've got direct substitution planned, factor and cancel, rationalizing the numerator, and finally ending with special limits. Our first method of determining limits is direct substitution, where you just plug in that value into the function. You can see if I do this using properties of limits by taking out this 4, we get 81. You can also double check this graph that as we are approaching -3, we're shooting way up towards that 81. So just plugging in our value can find our limit. For this problem, we're encouraged to explore the limit graphically. If we pull it into Desmos, we can see that as we get towards that 1, we get an undefined thing. So, whoop, whoop, there we go. But we can kind of look at those values and we can estimate what that limit is. It seems to be going towards 1/2. So, oh boy, it would be real nice if we didn't have to make a table or a graph in order to be able to figure out what that limit is. Well, that's what this idea is can we sort of factor cancel? Can we factor what's going on here and cancel out some of these values in order to be able to determine what our limit is? So let's try that. Let's factor the denominator. We can make this the limit of x minus 1 over x plus 1, x minus 1. And then, hey, those two things are able to cancel each other out. So we're left with just the limit of 1 over x plus 1 as x approaches 1. Now before, if we tried to direct substitute into here, we'd have 1 minus 1 over 1 squared minus 1. Well, that's 0 over 0, and that's just a whole mess. So that's not working. But over here now, when we direct substitute, we get 1 over 1 plus 1, which gets us that 1/2 that we saw on the graph. So if we do this factor cancel, we're able to evaluate limits that we couldn't direct substitute. In this problem, I go through my methods of determining limits. First, I try direct substitution. Well, I'd have 4 minus 4 in that denominator. That's not a good idea. 2, I go to factor. I can't factor cancel anything because that's not factorable. So what am I supposed to do?
I'm not sure. I'm afraid we need to use math.
What I can do is I can use a reverse of rationalizing the denominator. Someone had this expression right here and rationalized the denominator because we don't like square roots in our denominators. However, that's preventing me now from evaluating the limit. So I am going to rationalize the numerator in order to potentially cancel some stuff and be able to get my limit. So I'm going to multiply the top and bottom by the converse of the numerator. The converse of that numerator is copying that numerator, but between those two terms, I want to change the sign. Instead of a subtraction, I've got a multiplication. What that allows me to do is create a new limit where I can square the first thing, that x plus 5, and I got just x plus 5. The square root of x plus 5 squared, it's just x plus 5. Square the last thing, the 3, which is a 9, and then slap a minus in the middle. Now, that denominator, I mean, you could FOIL it, but our goal is to cancel later. So let's just leave that multiplied together, that x minus 4, and then the square root of x plus 5 plus 3. My gut reaction in those is to FOIL them, but don't. You don't want to. You'll just make more work for yourself. That numerator, and here's why, you can see becomes an x minus 4. Ooh, that will cancel with my denominator. Just like that. So now I have the limit of 1 over the square root of x plus 5 plus 3. And this is as x is approaching 4. Now let's try to, ooh, that's too long. Now let's try to direct substitute again. Well, if I put this 4 in right here, I'd have 4 plus 5, that's 9. Square root of 9 is 3. This equals 1 over 3 plus 3. Hey, that's a sixth. And there is my limit. In this problem, I go through my methods of trying to evaluate my limits. One, I try to direct substitute. 5 times 0 is going to be 0, and that's not going to be very good. Two, I try to factor. I can't factor sine, so no. Maybe I want to rationalize my numerator. There's no even freaking square roots in there. So what am I supposed to do?
I'm afraid we need to use math.
Fortunately, we've been given some little tricks. These are true statements that we can use for now. We're going to learn later about where they come from. But for now, we're just going to assume these limits and have them in our back pockets in order to be able to evaluate some of these transcendental functions. So what I do have is this is really close to that one. However, it's got a 5 in there. Using our properties of limits, we can say that, hey, this is equal to the limit. I'm first going to manipulate that inside of 1/5 of sine x over x. If you've got a constant inside of a limit, you can bring that constant in front of our limit. And then we can apply those like kind of given statements. This is the limit as x is approaching 0 sine x over x, which is right up here. So we know that this limit is 1 times that 1/5, and boom, there's our limit, 1/5.